Welcome, CP Finite, to Chapter 7.1, the Introduction to Probability. A lot of these topics are going to deal with counting techniques, but let's get right on into it. Basically, probability is the number of ways an event can occur divided by the total number of events. Okay, so in particular, up top we're looking at one event, okay, over all of the events. So it's really counting and counting again. The key thing with probability, it is always equal one of the key things with probability is that events probability always adds to 1 or 100%, and it cannot be less than 0. So it always adds to 100, and probability of some event is always greater than 0. You cannot have negative percentages, okay? So let's get into some of the examples. The table below represents the sample numbers at a Penguins game versus a Flyers game at PPG Paints Arena. Fans were asked which team they were rooting for, okay? So hypothetically speaking, let's say there's a sample of men and women here. Amongst such are Flyers fans, Penguins fans. They had to pick either one. And one idea to do first is always tally up the total. Again, totaling everything is pretty much the first thing you're going to want to do. So we have 800 men in total. We have 800 women in total. And if we go down the columns as well, we know of Flyers fans, we have 550. Penguins fans, we have 10,050. And in the end, both of these columns, boop, 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 and this row boop, 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 should equal the 1600. So if you do that, it checks out. Now, some of the questions. So let's imagine we were randomly picking guests from this sample. I want to know the probability they like the Penguins, okay? Well, there are 1050 Penguins in the crew, and over all of the guests, there are 1600, okay? It should hopefully not be too challenging to recognize that. So that's a penguin. Okay, so you can certainly simplify that, but for our sake, for time, I'll just leave it as that fraction there. Probability that a random male from the sample like the Flyers. So here, I'm just looking at the males that like the Flyers. There are 300 guys that like the Flyers. I'm selecting from the entire sample, men and women, so it's 300 over 1600. And that is the case there. Now, the probability a guest from the sample did not like the Flyers, so it's actually really similar to part A, just worded differently. Well, if they didn't like the Flyers, that means they're either a man or woman that liked the Penguins, so there are 10,050 over 1600. Okay, 1,050, not 10,000, Dvorsky, okay? And the probability of selecting a woman that likes the Flyers, well, there are 250 ladies that like the Flyers. And again, if I'm selecting from the entire sample, that's just 250 over 1,600. Again, you could be simplifying these, like right off the bat, you know it's 25 over 160, and goes from there, okay? But for our sake, we'll just keep as fractions. Types of events. The other piece is there are two types of events. We kind of talked about this with counting: overlapping and disjoint or mutually exclusive. So overlapping events are events that have elements in common. And you should hopefully recall last chapter we looked at mutually exclusive or disjoint, and these are events that have nothing in common. No elements in common or shared. So a few different ways to look at these. First, let's say you're rolling a die. The probability of getting an even number. Well, there's a total of 6 things on a die. Even numbers, if you think of those as 2, 4, and 6, okay, you know the probability is 1/2 or 3/6. Okay, that's the probability of event A. Probability of event B, you have a number greater than 2. Well, let's think about the numbers greater than 2, strictly greater. Okay, so that's 3, 4, 5, 6 over 6. So it's really 4/6. Now, probability of A or B, they're overlapping, okay? So notice, this is where it can get tricky and why I recommend writing out the numbers. A or B means, again, if we were to write everything out, that means we are getting either a 2, a 4, or a 6, that's from A, or we're getting a 3, a 4, a 5, or a 6. Okay, that's from B. Well, we counted things twice. We counted 4 twice, and we counted 6 twice. Okay, so we really have to subtract the number of things that intersect. So really the probability, since we counted those twice, we're left with 2, 6, 3, 4, and 5. Okay, and the probability then would be 5/6. Okay, since we counted everything twice. And you think of it, the only number that is out of our spectrum here is 1. So it does make a little bit of sense. Now, if you're rolling a 6-sided die and say I get the numbers 1, 2, 3, okay, well those are simply 1, 2, or 3, so the percentage of that is 3/6. 4, 5, or 6 is 3/6. If we look at these elements, okay, they don't share anything in the total. If I were to write them out, 1, 2, 3, so that's A, and then I add that to B, okay, 4, 5, 6, nothing repeats, and basically if you roll a die, you're going to get one of these numbers, so it's 6/6, or 100%, okay? Overlapping events share something, mutually exclusive do not. Okay, another example, cards. We're going to do a lot with card decks. I kind of simplify it here for us. We have 4 hearts and 4 spades, each numbered 1, 2, 3, or 4. So an example of an overlapping event, let's say I have a spade. So the spades, again, are 1, 2, 3, 4. How many total cards are there? I have 8 total cards. So that's a good thing, again, to know for probability. Really, it's 4 out of 8. Keeping in mind, it's 1, 2, 3, and 4. Now, let's say for hearts, and I'll even use red, or probability that I just get a 1 or a 2. Well, let's think. We have the 1 and 2 of hearts, and we also have the 1 or 2 of spades. Spades. That is my best spade. I'm just going to erase that. Okay, so let's think here. If I were to combine the two, so A plus B, A is 1, 2, 3, 4. And I'm going to again add 1, 2. 1, 2. What did I count twice? Well, this 1 I don't need again, and this 2 I don't need again. So I have 1, 2, 3, 4, 5, 6 over 8. I have a 3/4 chance. Okay, so if it helps to write it out, I recommend doing that. Let's say on the other side here, I get a 1 or a 2. So that's either a 1, a 2 of spades, or a 1, a 2 of hearts. Or I get a 3, so it's either a 3 of spades or a 3 of hearts, well, if I were to add or union these two, I'm really left with 1, 2, 3. And I'm really left with 1, 2, 3. Nothing repeats, and that's why they're disjoint, or I have 6 out of 8. Again, not that they're going to be the same probabilities, but again, using the same cards, there are 8 total. Numerically and symbolically looking, okay, this is what's going on. It says probability of event A plus probability of event B minus what they share. Got to equal to 1. So, if we think of this here, A and B, so probability of the intersection, well, probability of A is 0.5. So just using the formula, use the formula. Plus, okay, B minus the intersection, so I'll just write intersection. It's got to equal 1, okay? So I actually have everything filled in there. Well, 0.5 plus 0.75 is 1.25 minus the intersection equals 1. Well, if I subtract that, that means the intersection must be 0.25, or PA intersect B is 0.25. So that is symbolically what it's saying. It's saying the intersection, since it has to equal to 1, they must be doubling up 0.25. Now the spots on the other end of the spectrum, if you take your two events and they equal 1 off the bat, okay, so these two here, 1 equals 1. Notice there's no intersection, or it's equal to 0, so these would be known as mutually exclusive. Okay, so what I'd like you to do is go on Google Classrooms. Okay, I would like you to first give an example of 2 events that are disjoint or mutually exclusive. Disjoint, J-O-I-N-T. And 2, I would like you to give an example of 2 events that are overlapping. Okay, and that's all I got for you guys. We will do some more practice tomorrow. Adios, amigos.